My name is Alastair Rucklidge. I'm a professor in applied mathematics at the University of Leeds. And today I'm going to be talking a little bit about rational functions. I'll be doing some examples of partial fractions and integrals that involve partial fractions, and we'll end up doing a few manipulations of rational functions along the way. I'll be doing two examples. So the first example is the simpler one, which I'll introduce here. So this is, we're going to do an integral which is 4x squared divided by 2x squared minus 7x plus 6 integral with respect to x, so dx here. Okay, so how are we going to proceed with this? Well, we've got here a rational fraction here. We've got a polynomial on top, a quadratic function of x. On the bottom, we've got another quadratic function of x. And as it stands, it isn't an integral that we can do. So we have to go through some various simplification stages before we'll know quite how to do this integral. So what we could do is we could first of all try and make it as, here we've got a quadratic function and a quadratic function. These things are the same power. So we could simplify it a bit by pulling out the quadratic behavior and then leaving a linear polynomial in x, first order polynomial in x, divided by the second degree polynomial on the bottom. So how do we do that? Well, what we want to do is to alter that x squared and make it look a little bit more like what's in the bottom. Okay, so what I'm going to rearrange this and write it as the integral. So first of all, I'll take it a factor of 2 out. 2x squared divided by 2x squared minus 7x plus 6 dx. So that 2x squared was pulled out. So I've just taken that 4 and written it's 2 times 2. And that was done to make that 2x squared look like the first part of the stuff in the denominator. So this we can now write as, I need a bit more space, so let's do it as the integral here 2. And now I want to make the rest of this look exactly like the denominator. So let's make it as 2x squared minus 7x plus 6. Okay, now I've subtracted 7x and I've added 6, so I have to add 7x and subtract 6 to make it so that I haven't actually changed anything. 2x squared minus 7x plus 6, and that is an integral dx. Okay, well now I've got something here that looks precisely like the denominator, and there's a few bits and pieces left over. So I'm going to split this up. So this is going to be 2 times this 2x squared minus 7x plus 6, all divided by 2x squared minus 7x plus 6, and then plus the rest of it. So there will be 2 times 7x minus 6 divided by 2x squared minus 7x plus 6, all integrated with respect to x. All right, now we're at a point where we can simplify things a little bit. We've got the bottom here, the denominator has a factor that's the same in the numerator, so we can cancel those, and we're going to be left with this integral here, which is now 2 plus 2 times, well, I might as well expand it out at this point. So that is 14x minus 12 divided by 2x squared minus 7x plus 6, all integrated with respect to x. Right, so we've made a little bit of progress here. We've got to the point where we started with a quadratic function of x divided by a quadratic function of x. We've now simplified that, so it's now just a number here, 2, plus a first degree polynomial in x divided by the quadratic polynomial in x. So that's the first step in the simplification. The next step, if we want to do the integral, well, we're still stuck. We still can't do that integral as it stands. We can do this part. We can integrate 2 dx. That's easy enough. That would just give us 2x. But this part, we have to work on it a little bit further, and what we're going to do is use partial fractions. So let's proceed with that. We want to write 14x minus 12 over 2x squared minus 7x plus 6 as the sum of two simpler fractions. Well, to do that, we need to know what the factors are. We have to be able to factorize this thing on the bottom. So, right, so we need to factorize this 2x squared minus 7x plus 6. So we could write it, okay, so if you're good at factoring, okay, so hopefully it's got factors that involve integers, and if it does, we've got a chance of just making a few guesses and seeing what we can make work. So something like it will be 2x here plus something, and then it would be x plus something, and that gets the x squared bit right. Yeah, we've got this here 2x and the x, that will give us the 2x squared, and then we've got to choose these somethings so that they make the rest of it work. Now what works there? Well, 6. The factors, the way you can multiply out 6 is 1 times 6 or 2 times 3. And so these numbers here, hopefully some combination of 1s and 6s and 2s and 3s with pluses and minuses will give us something that works. Now if you're good at this kind of game, you can make it work, and we can make it work if you want to, but I'm going to, instead of this, use the quadratic formula, because that will work regardless of whether you're good at factorizing this. So let's put factorization to the side. We'll use the quadratic formula instead. It's always good to try to factorize first, and if that doesn't work, don't be afraid to use this, because this hopefully should always work. So the quadratic formula means we're thinking of this as ax squared plus bx plus c, and the roots equal 0. The roots of that are minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So here b is minus 7, so we'll have x is minus 7, so that's 7, plus or minus square root of b squared, so it's minus 7 squared, b squared minus 4ac, so it's minus 4 times 2 times 6, all divided by 2a, 2 times 2 here. So here what we're doing is we're putting the denominator equal to 0 to try and work out how to factorize it. Okay, so this gives us x is 7 plus or minus, what have we got here? It is square root of 49 minus 4 times 2 is 8. 8 times 6 is 48. All divided by 4. So that is 7 plus or minus 1 divided by 4. So that is either 8 over 4 or 6 over 4. So 8 over 4 is 2. 6 over 4 is 3/2, and that will give us our factors, which I'm going to have to make use of the board here. So I've just rewritten it slightly here. We've already simplified 4x squared over 2x squared minus 7x plus 6. We've written it as 2 plus 14x minus 12 over 2x squared minus 7x plus 6. And we're trying to factorize the denominator, so we wrote x squared minus 7x plus 6 equals 0, and we've used the quadratic formula to get x is 8 over 4, which is 2, or 6 over 4, which is 3/2. And now we're in a better position to factorize this, so this we can write as x minus 2, which gives us that root, and I beg your pardon, I lost a 2x squared here. So that's 2x squared, so we need a 2x here, and to get that to work, that should be a 3. So to get x equals 3 over 2 to be a root, we need 2x minus 3 here to be the factor. Now let us just check that this works. X times 2x is 2x squared. The minus 2 times minus 3 is plus 6. And then we've got minus 2 times 2x, which is minus 4x. Minus 3 times x is minus 3x, which adds up to the minus 7x that we want. Okay, so that is now working. And now what we need to do is try to write our 14x minus 12 divided by that denominator as a partial fraction. So we've got 14x minus 12 divided by a factor which we can now write as x minus 2, 2x minus 3. And we're going to write that as something divided by x minus 2 plus something else divided by 2x minus 3. What do we put on top? Well, we put on top here polynomials that are 1 degree less than the denominator. So here, these are first degree polynomials, just x minus 2. So we're going to put a constant up here. And we're going to here also first degree, so we just put a constant up there. And we need to choose these numbers a and b so that these two things on the left and on the right are identical. So they're exactly the same for any value of x. So to proceed with that, we'll put this over a common denominator. So that is a times 2x minus 3 plus b times x minus 2, all divided by x minus 2 times 2x minus 3. And for these two, the left-hand side here and the right-hand side, to be identical, the 14x minus 12 should be exactly the same as the numerator up here. And I'm going to write that numerator as something times x. So how many x's do we have? We've got two ax's here, and we've got a bx. And then we've got minus 3 a's there, and we've got minus 2 b's there. For these to be exactly the same, the coefficient in front of the x should be the same on both sides, and the other coefficient here that doesn't have any x's should be the same on both sides. So we've got 14 is equal to 2a plus b to make that and that the same, minus 12 is equal to minus 3a minus 2b to make that minus 12 and that to be the same. So we have a little excursion into linear algebra to solve this pair of simultaneous equations. You can do it by any means you like, of course. One thing that will work is supposing we took the top equation and multiplied it by 2 and added the bottom equation, then that b would become 2b. That would cancel with the minus 2b when you added them. So let's just take that and multiply it by 2. And that gives us 28 is equal to 4a plus 2b. And if I write the other equation underneath, minus 12 is minus 3a minus 2b. And if I add these two, you get on the left, you've got 28 minus 12, which is 16. You've got 4a minus 3a, which is a, and the b's cancel. So you get a is 16. And from that, you can get, well, what's b? b is 14 minus 2a. So that is 14 minus 32, which is, well, see, 32 minus 14 is 18, so it's minus 18. Let's use that value of a. So now we know what numbers to put here. A is 16. B here is minus 18. And we're done. So I can erase all of this because we've done the calculation that we needed. We don't need this anymore now that we've got those numbers. Although, you know, it wouldn't do us any harm just to check we've actually got this right. So let's just multiply it all out just to make sure it's okay. So it is 16 times 2x minus 3 plus, then it is minus 18 times x minus 2, all divided by x minus 2 times 2x minus 3. So that is how many x's do we have? We've got 16 times 2, so it is 32 minus 18 x's, and then we've got minus 3 times 16, which is minus 48. And how many here? We've got minus 18 times minus 2, which is plus 36, all divided by the denominator, which is, see, 32 minus 18 is 22 minus 8, which is 14x. And here we've got minus 48 plus 36, which is indeed minus 12, all divided by the same thing. So that actually has worked out all right. By the way, doing this extra step of checking is an extremely useful thing to do. You might think you're just sort of solving something that we've already done, but it's this checking stage that is the thing that tells you that every step of this calculation is being done correctly. And it's the thing that gives you the confidence that the final answer is going to be correct. Okay, so we've now separated this rational fraction over here into its partial fractions, 16 over x minus 2, minus 18 over 2x minus 3. If you remember, the point of this was to try and get this into a form that we could integrate. So let's put this integral over here. So this integral is now the integral 2 plus 16 divided by x minus 2 plus, then it is minus 18 divided by 2x minus 3 integral dx. And now this is in a form where we can go ahead and do the integrals. So this is, well, we need to do one last step. You can integrate this thing directly, but it is a little bit easier if we make the coefficient in front of the x equal to 1. So I'll just write this as, so that is 18 is 2 times 9. So I'm going to cancel, so I'm going to write this as minus 2 times 9 divided by 2 times x minus 3 over 2. And then we'll cancel the 2's. Okay, so it is minus, and this, beg your pardon, my x's and times do look a little bit similar. So, and that's another interesting thing to look out for is when you're writing something, make sure that you can read it correctly. So I'd written there 2 times 9, which looked a little bit like 2x9. Okay, so there we are. We've got this thing is now minus 9 divided by x minus 3 halves. So we can do the integral here. The integral of 2 is 2x. The integral of, well, there's a 16 out here, which just comes out front. The integral of 1 over x minus 2 is the natural logarithm absolute value of x minus 2. And then the integral here of the minus 9 over that, so it's minus 9, integral of 1 over x minus 3 halves is natural logarithm of x minus 3 halves. And then finally, you put a constant of integration. Okay, so that was the first example of doing an integral of a rational fraction. We started with this, a fraction here, 4x squared over 2x squared minus 7x plus 6. We simplified it by dividing into two parts, the constant part, and then a fraction here where the numerator had a lower degree than the denominator. We did partial fractions to split this thing up into its component parts. So we split it into something over x minus 2, something over 2x minus 3. Having got it into these three parts here, each of these is something that we can integrate, and then we can proceed.